Acredito que foi tudo startado, tá? Tanto a transmissão quanto a gravação.
Só um instantinho.
Ok.
Só um minutinho, queridos. Bom dia a todos e todas. Tenho o prazer de iniciar essa banca de defesa de mestrado do Welcome, Sil, dessa banca de mestrado orientando o Rodrigo Ferreira de Souza, no programa de pós-graduação, doutorado e mestrado profissional em inovação tecnológica da Universidade Federal de São Paulo. Ele apresentará o trabalho Skill Development through Artificial Cognitive Systems and Social Robotics in the Field of Technological Education. Tenho o prazer de estar aqui com os colegas, a professora doutora Maria Elisete Kunkel, do Programa de Pós-Graduação em Inovação Tecnológica, qual já agradeço a participação. Também do pesquisador sênior da Universidade de São Paulo, professor doutor José Reinaldo Silva, da Mecatrônica, Departamento de Mecatrônica da Universidade de São Paulo, também agradeço enormemente, e também da participação do professor doutor Ronaldo Prati, da Universidade Federal do ABC. Então, aqui nós vamos iniciar essa apresentação com o Rodrigo. Ele tem até 40 minutos para apresentar o seu projeto, né, a sua defesa, e depois nós passamos para as considerações de cada um dos nossos aqui convidados. Então, Rodrigo, desejo você boa sorte e a partir desse instante está valendo os 40 minutos da sua apresentação.
Okay, thank you, Professor Walter. I will start right now. Just to introduction you, we have here our campus. Should we start the first slide here? Just to introduction in the ICT, Unifesp, an Institute of Science and Technology, from the Postgraduate and Doctorate and Professional Master's programs in Technological Innovation at Federal University of São Paulo. Well, the project that I will present for you in this moment is called Skill Development through Artificial Cognitive Systems and Social Robotics in the Field of Technological Education. I have the supervisor, Professor Walter, and the co-supervisor, Professor Kim Baraka, from Vrije University of Amsterdam. And again, say thank you to Evaluation Boarder, Professor Ronaldo Prati, Professor José Reinaldo, and Maria Elisete Canco. Our lemma to develop this project of research, it is Nanogiganton Emeris Incidents from Bernardo's Carnotensis. That's allow us to make some reflection about what we are doing in the academic field and how we can improve ourselves and our research from the perspectives, from the beginnings, from where it starts, the fundamentals and the basis concepts from the gigantons scientists in the past and what we can do from now. Well, our agenda is very quickly. We have only 8 topics here.
Rodrigo, one moment, please.
Yeah.
No transmission.
Let me see again.
Presentation in YouTube or stream.
I don't have the option here to make the transmissions. It is that is strange.
Tem aquele link que você enviou.
Yeah.
Eu queria entrar, está dizendo que está a transmissão, mas não começou. Deve ter algum botão aí que diz transmitir junto, não é?
Sim, tem a opção gerenciar streaming. Ah, tá. Transmitir e iniciar internamente. It is here, the link of the transmission. I believe that is working right now. Just to check here.
Ok. Yeah.
It is working?
Okay. This is work.
Okay. Sorry for that.
Thank you.
Can I restart?
Yeah, it's work.
Okay. Well, just talking again to anyone that's...
Talking again.
Okay. For everyone in the audience, I know that have a lot of persons with us right now. I'm sorry for the mistake from the beginning, but our intention here is to present you our campuses, where we are from, the ICT, Unifesp, Institute of Science and Technology at Unifesp. This master's that I'm graduating right now is part of the program of postgraduate and doctorate and professional master's program from the Unifesp in the technological innovation. The project we are talking is entitled skills development through artificial cognitive systems and social robotics in field of technological education. I have a supervisor, Professor Walter, and co-supervisor, Professor Kim Baraka from University Vrije at Amsterdam. And here in the evaluation board, we have Professor Walter president, and also Professor Ronaldo Cristiano Prati from UFABC, and José Reinaldo Silva from USP, and Professora Maria Elisete Canquil from Unifesp. Our lemas is Nylon Gigantus Emerging Silence from Bernardo's Carnotensis that allow us give some perspective and the reflections to understand what we are doing right now and how we can improve ourselves from the perspectives from the great studios and great creators of those concepts. For our agenda, we have only 8 topics, and the first one we'll try to only give for anyone here a little overview about technological education and what we are talking about in educational field, what was our motivations, of course, the systematic review and research questions, materials, methodology, lab experiment, we think include our proof of concept, and the conclusion of this project. So to start, the first point that I have a lot of interest to explain and have very clarify for anyone here, it is analysis technological field of education in 3 great aspects, and the introduction anyone here about what we have done. So our first interest is understand what we have right now and what we will have in the future, and where it is this project in the moment that we are facing. Second topic is about definitions. So it is important understood that skills, it is everything that allow us to solve problems or develop solutions. And third point is how we understand this like an innovation, because we are trying to create some mix of combinations, but based on deep knowledge between 4 years. But looking in this perspective, what we have in the complexity in this each one of these areas, like education, artificial cognitive systems, social robots, and of course, cognitive psychology. So there's looking in a kind of overview that we can analysis. It is more than to see what are our origins and what kind of a knowledge or perspectives was created in the beginning from the vocational education, like apprenticeship systems in medieval Europe and trade schools in the Industrial Revolution. Here in Brazil, we have SENAI, or Institute Federal of Educations, and what kind of influential figures have this kind of importance? Like here in Brazil again, we have Nilo Peçanha and Charles Prosser in USA. Creation of this kind of legislations and laws that creates a lot of definitions about the technical education. And the final starts the transition. We can look to handmade process and how improve to the traditional manufacturing to developing some kind of vocational training. And then the present, we are facing a moment of the transition, because we are in the current time from the perspective to understand how kind of integration can make a difference in the concept of automation, Industry 4.0, robotics and data analytics like IoT, and how can we create some blend of everything of these and combining this kind of situation and what is the reality from the learning and understood about the researches and combination with the classroom instructions and other resources. So the skills, like I was saying before, the quality to improve and creating new ways to solve problems, and look to the workforce and how can those aspects improve themselves, but not only in the technical skills, but also in soft skills like critical thinking, communication, adaptability. And in the future, what we are facing, it is understood that we are looking more tools that have personalized learning paths, where each individual is understood how they self is really is, and understand how can we using data analytics and AI in the truth to understand and to create learning experience for exclusive individuals. Now, of course, this include virtual and augmented reality integration, and how we can improve and revolutionize vocational education from that perspective. And to final, the design will be human-centered with emphasis and principles, and how can we create some holistic skills development. That is our main and more objective here. So just to illustrate these three aspects, The first one in origins, we have figure on photography from the School of Apprentices and Artifices from the state of Paraná, the city of Curitiba, in the 14th. We can realize how the vocational education starts with no preparation from the environment, but with kids and the youngers to learn some skills. What we have in the present, with a lot of tools, kits, and concepts to give some knowledge to the students. In the future, our perspective will facing together robot systems, learning at the same time the students. So that is where we are looking. Then to our motivation, technology needs to be used to solve a challenge. This is our principles and our goals. So it is from that perspective we are looking to the teacher and also, of course, to the individual student. So to go more objective here and talking about the project, of course, the development was using the architecture of SOAR. We have an implementation in proof of concept in SENAI and support from Solid Technologia. The first topic here about those goals, it is our intent to modeling and planning the artificial cognitive systems to help teaching learning process with focus in youngs, starts from 14 years old, using SOAR. And we are also developing a low-cost mobile social robot with a web interface. So that was our deliverable. And third point here, it is generate those models, those methodology to help and to share with the community to improve and go to analysis the performance from the psychological, pedagogical performance and models to understood students and teachers. So about the systematic review, we have two principles here: systematic literature review and mapping DSR. So we follow the protocol, objective, PyCock, research with questions, keywords and synonyms, search string, sources, and selection criteria. So here we select three sources. From any source, we have those appointments here. I not to go deep in those numbers. I'm will focus on proof of concept. Those numbers you can see in more details in dissertation text. Inclusive criteria is the same. Quality assessment criteria with cutoff 3.5. In Parsifal, we use a Prisma to select and help us to filter those papers and works that we look and have some similarity with our job. Here we could see that our field of research is very pulverized around all of the world, and a little discrepancy on highlights in the USA, Indonesia, and Russia, and the other ones is very equilibrated. Some highlights that we are looking to understand and see with relevant. From those works, 14 using simulator, 10 not mention any kind of research they are using. It was more scientific and more theoretical. And 6 educational robots, 4 from social robots, and 3 from mobile robotics. And the educational field that those jobs are looking for, 15 look into college and university and high school, 10 to elementary school, and 8 to early childhood school. And 7 in our field, the technological and professional education with applied to workforce. So the main finds and main results that we see was the positive relation between when we start to using robotic platform to increase and help to motivation students to learn more. And that is very important to understand that when we have some physical tools with the students, they allow them to create some primitive connections with the subject. So this allow us to understand a little from the patterns that we see. That includes the integrations, the robots in the context from the subjects that the students are facing, but highlighting the potential that this kind of personalization from the learning person can deliver through the artificial intelligence. And discussions is centered on the importance to have planning from this perspective pedagogical to design and implementing this kind of innovation in the education field. And systematic review conclusion, was to demonstrate about how our integration, cognitive robotics in educational fields can erode the promise from the fostering activity, learning and promoting critical thinking, to have contributed to advancing in the methodology from the educational perspective that, of course, need to improve. So, again, just to connect with our lemmas, 9 gigantes emergence incidents. Our giants here is like LiDAR with the man-machine symbiosis, Paulo Freire from dialectical, educational, and of course Howard Gardner with the theory of multiple intelligence. And in this perspective, what we are facing in the current moment of the academy and the scientific field, we can highlight the work from the Kim Baraka, Alessandro Schiuti, Tony Bopemi, and of course Walter Teixeira, with application in cognitive and social robotics fields. So goes to the projects. Our challenge, it's 4 topics here, just to start for the beginning. The development of technological skills to young and the adult people. Artificial cognitives can help the process to develop technological skills. We are looking to these comprovations or not, of course, and elementary assumptions about how is the best way to implement these solutions. We tried in some strategy, but we have some criticals about this perspective too. And final, what is the best way to collect these data, mensury, analysis, the metacognitive concepts from the psychological, pedagogical layers and frames to understand the efficacious, this what we are developing. Here a little about all the main materials and methodologies that we are using. So there is a very important aspect here for us, the symbiosis dialectics of intelligence. So when mix that we look to symbiosis from the perspective LIDAR, dialectics from Paulo Freire and the intelligence from the Howard Gardner. So this mix allow us to create a new concept and understand how the symbiotic relation interaction between humans and machines are just in the beginning, but it is very clear that is will be a continuous improvement and looking to find how we can really create the kind of symbiotics relations. So we can extract three aspects. So multifaceted intelligence, because each human being have 9 of aspects of intelligence, of course, from how to gather, and symbiotic interaction and dialectical learning. So what we have done about the social robots, we create our own educational robot with low-cost equipment in the first place. It starts with perspective from the virtual system, but we create a physical to interact with the students, and of course the web app applications. Here about our architecture, in the overview, we have a platform that could be hosted by cloud server or local on-premises kinds. And in the platform, we have 3 agents running SOAR architecture, and the Raspberry Pi hosted in the social robot, responsible for control the robot, like object manipulation, physical interaction with user, emotional expressions. And here we have 2 agents for in 5 in the future. Soon I will explain about the agents. And the smartphone or laptop from the students, they could interact with an interactive book that is hosted in the server, and interaction between the robot together. And the other side, we have the teachers portal to understood performance reports and see how the students are improving themselves in the systems. So far, we have the architecture that are building to create a lot of kind of different systems. So for us, it was very interesting to working with low memory and working memory. A kind of capacity of represent forms and ways to each one will study and understand from this process. The block diagram, just to explain about where Soren is host in the Raspberry Pi. We're running like web server to connect with the web app application and to control the elements and the components from the robot. Not only the sensors, ultrasonic and the photoelectric sensors, but also the motors, the servo motors from the arms and the wells. So to talking about these cognitive agents, just a little overview from the everything with more details we can see in the dissertation text. But the first agent, it is responsible to coordinate the student profile. So this agent was modeling to understand, of course, using some forms to interact with the students. The students can create some answers to our agent. And based on these answers from the students, we can modulate the profile from the students. That is allow us to understand if these students have more affinity or more dominations to learn using logical, mathematical fields or linguistic fields. So the second agent is to control our backlog of content. So this agent just only to the backlog from the content and understand what is the next activity that that the student need to understood to improve themselves. And to help this, we have other agents called the storytelling coordinator that will modeling and create some paths to allow the students. Each student have the only and the single path to learning. And the fourth agent is a robot emotional and mood coordinator that is responsible for control the expressions and light from the robot. And the 5, we have a coordinator from navigation to help us to move forward, move back, move left or right, and change those arms from the robot. Here, just to explain why social. So why not social? Because when we don't have more than a primitive concept with between humans, we are talking here about psychological field. It is when we have some kind of connection in the expressions in the field or in the components and the tools that allow us to create an uncontrollable connection with our subject. So here we could create and change in 26 expressions by eyes in the robot. Here is the little proof of the concept that students improve in the classroom to before they make the assembly of the robot. And here are some kinds of versions that we have from the starts of the beginning, our research, and then when we decide input some eyes in our bases, and also arms in the robot to collect some objects. And the first demo of hands-on made, the first model, physical. And then in open source model using wood, the plaques and shapes of wood in the way that was assembled by students. And just to explain, in our proof of concept, the web app side, here is a little example from the subject. Here was amplificator, operational amplificator, as a single component from the PCBs and the electronic fields. So we have the same content and same goal of content, but with structure of content in 4 different ways. So from a student that we realized that these students have musical affinity in high level, we can direct into the students and content based in music, in music, musicians and instruments. But the content we're talking about the subject as an amplificator, operational amplificator. The same way to a person, an individual that have a lot of affinity with spatial, and we will send to add to them a knowledge about the spatial fields. So like here, mystery, the environments. And logical mathematics, we are introduction, the same goes, but with another different approach. To the natural, the same goes with another different approach, but the same content. Here about our platform, web and web app. So the students just connect to the RED, the network in the robot, and then could access this kind of interactive book. And here are some experiments and records from the implementation that we have in the Rondonópolis and Mato Grosso that allow us to create some tests and proof of concept with 301 students and 10 teachers. Here is how works our testing strategy. That is a concept that was recommendation from the Professor Kim Baraka. So we start with 1 teacher, 10 groups of students in what we call the group A. In the group A, we are looking to the students that have affinity with good affinity with kind of intelligence. In group B, we have 10 students, the same teacher, but with the opposite kind of intelligence, non-dominant for these students, the kind of content that we will provide to the students, and the group control that have the traditional classes from the teachers. So this was the model. We repeat this model for 10 times, and in this the only one schools. Here is a plan to how this classes works. So we have 3 sections with each one group, and for each classes, this follows those structures over here. So group A with students with dominant intelligence type, group B non-dominant intelligence type, and group control with traditional classes. So our results, the most important, so some demographics informations. For 4% is female, and for 16% is male, and age on road here in clear is the teachers, and the green is the students. So our group is more younger in the adolescents, and for teachers, 3 women and 7 men, in the kind of the graduations of those. The proof we are looking about to understand how the families from the students and the teachers are providing about the incomes, and we have here about the median equilibrium in the 3,000 revenue income in the reais. This is the most important dashboard that we have, because with this structure we can understand how our public is mentioned. So to understand this graph, the first one here in green, it is these students that have great affinity with this kind of intelligence. So in our public, we have a little discrepancy, highlights from the linguistic students that show us that they have more affinity with this kind of knowledge. And when we look to the 9th position here with the red, we see that those students have not affinity with spatial kind of knowledge. And in this perspective, we can look in the graduation to the first more accentuated kind of learning, and the lower kind of learning in the affinity of intelligence. So in our approach, when we just to explain this, is very important. We have tests that the schools of SENAI and Rondonópolis applied to the students. Is very common and regular for these students, taking the steps from the classes to understand how is the performance from the students. So we choose the same tests that they have historical recording, so classes from the 2020, 2021, 2022, and apply the same tests with our group of students. So in our group B, we don't see not so relevant difference. Of course, we have a little difference, positive difference here, maybe because they are using robots and systems, we don't know, but we see a little difference here. And when we look to the group with dominance and intelligence that receive the content from this kind of intelligence that they're looking more, we look at great highlights and great discrepancy from the performance from these students, including when we analyze against the control group. So this makes some significant improvement around the 35% in direct comparison when guessing again. And here a little representation about the intelligence by intelligence, about the capacity of retention of knowledge of each kind of profile from these students. Of course, this is on records of the masses, so allow us to understand that kind of student could make more retention, but it's very important to understand that we have one subject that have a bias because we are talking about robotics, so electronics and assembly. So that is we don't can forget that. And the final dashboard here, it is just to understand from the feedback from the students what's easier for you to learn. The group A, a lot of students agree with the more easy to learn in this way. Group not dominant intelligence agreeing 70%. Has your interest in subject increased? That not have a lot of discrepancy here in this direct comparison. Did you have a difficulty during the classes? The group A don't have the difficulties, very highlights over here. The group B a little difference, but representative. And do you believe that digital hybrid classes are better? Both groups agree with these questions. And some students, we could collect data from those parents. Schools allow us to do that. And our ask for was, did you notice your child become more interested in students or in this field? From the students that group B, they are more sharing with their parents. So this was interesting for us to see this perspective. So to final future perspective and expand the scopes from the technological and coverage expansion of the areas of their knowledge, not only the roboticals, but looking to electricity and machinery, a lot of kinds of areas that we have interest to expand this view and improve our cognitive modeling, because we understand that we really don't have the kind of symbiosis at the present, but we are looking to achieve that. And intensify the development of cognitive models with great capacity to identify personal profiles and improve this to be more accurate, to identify with more precision this kind of the personality from each student. And optimize on this data processing, but also collecting data from these elementary aspects, and present the projects to maintain some partnership with Carol to deeper research between a PhD program in the future. So I want to say thank you to anyone here in the audience, in the assessment and the evaluation board, and of course to my supervisor, Professor Walter Lima Jr., and my co-supervisor, Kim Baraka, and also to my invited Sil from the Pennsylvania University.
Thank you, Rodrigo. On time. Thank you. Thank you. Ok, vamos